There's all kinds of disciplines, even within semiconductors, that you could play in. Another dimension here is you can be at the university, you can be doing research, you can go to the industry. So again, figure out where you fit in all of this scenario. One way to, the problem that you see is a lot of times the goals are orthogonal, right? So if you're a researcher at the university doing a PhD, your end goal is to write publications. Professor van der Spiegel, right? And he does research, his students do research. The end in mind is to get grants, do research or publications, right? Which is quite different than the goals of an entrepreneur. As an entrepreneur, what you're trying to do is you got to create a successful startup. If you're trying to go get a job, you end in the result is to get hired. Not necessarily publications. With a PhD, maybe they'll look at what work you did in the past. But once you get a job, most companies won't require you to write publications. There are exceptions, of course, but in general, I'll tell you my own example. I went to work at Motorola after my PhD, and my bosses didn't care what I wrote a paper, but I wrote 2 papers in the year because I wanted those publications. So I was working at midnight trying to get those done. There was no requirement from my job to do it. So I'm just pointing out that there are orthogonal requirements, and you got to figure out where in the space you want to play. In my own career, I went into an industry job, and publications wasn't a major requirement. I did some, but different kinds of publications, right? I would do workshops, I would do magazine-type publications, not research publications. But the goal then is to be successful, go up the management chain, whatever your goals are. And I just wanted to show you that model because I think it makes a difference on where you plant yourself in your career development. By the way, if you're a researcher, I said I was going to show you this earlier. Copper and high K were 2 very important developments in the semiconductor process space. To give you an idea, if you were to do a startup, that whole idea was planted in 1984. It didn't get into production until 1997. It took 13 years to get into high volume production. High K Metal Gate took 14 years. So as an entrepreneur and startup, don't think of doing a startup in a new material. That's not the thing to think about, right? Here's a thought process on the timelines. If you're doing fundamental research or there's new materials or processes, they typically go into an advanced R&D where it gets vetted, make sure it can be integrated in the process. There's no side effects. So you got to do some reliability testing, on and on and on. Then you get into technology development and then manufacturing. So it's a long development cycle. Almost anything new that you're doing, you got to have a timeline. Here's an example, though, that the research could take a long time to get to manufacturing. Wanted to show you also examples of in automotive. So here's, if you look at the a very recent article on what kinds of things is sort of related to I showed you the chart of a picture of automotive with all the different pieces of electronics. You could actually do a startup based on any of these areas. Right? It depends on what your unique idea is and how that fits into this. So that's the reason to show this is lots of different opportunities. There's an interface charger, regulator, blah, 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 right? Sensors, great area for it. You know, we talked about the blind spot sensing. If you can create a solution that your competition, by the way, is going to be the automotive manufacturers, and be careful about that because they would integrate that sensor blind spot monitoring into the main electronics of the automobile a lot easier than you could as an outsider. So if you were doing an after market solution, applying it through a smartphone, for instance, might be a good way to do that. How you integrate that into the turn signal, I don't know, but I'm just indicating some thought processes that you can look at where there might be a need. So looking at another dimension here, so this is all the different things in a features in a ADAS device, and I just wanted to use this as an example that you could take anything here as an example. This rear side radar controller, for instance. There's probably some circuit in there that needs innovation. If it's standard off the shelf, maybe you don't just do that as a product, but you could then take that circuit design. Let's say you have a unique feature, you could become an IP provider. You can develop that circuit. If you can patent it, you can go license it. And by the way, you should look at that as an opportunity because that's the least aggressive way to get in and make some money. You won't make the same amount of money as a fabless IC company, but certainly could be a good way to get started. You could create a fabless IC company. You could decide to build a box, be a solution provider. You could provide a subsystem, or you could be the manufacturer, right? So that one I would cross off right at the top. You don't want to be a Mercedes, right? You could build a box. So here is the box, right? This is a subsystem that goes into the automobile. You could be this box provider, or you could be a chip provider that goes in here, right? So the number of different layers that you could play in, and you really have to figure out what's the problem that you're solving, according to the cartoon. Remember I showed you that? My primary suggestions for being startups could be these three areas. I didn't asterisk circuit design because people don't really buy circuit design unless you can create an IP block out of it, and in that case you would be an IP provider. Okay, so if all you got is a unique way to get a circuit design done, by all means write a publication, write a patent application, those are fine. But figure out if somebody really cares about it, are they going to really buy it? Right? Apply that cartoon. Oh, so this is the example of these three. I showed you this before, right? So this is the MacBook Air with a single USB-C port. And in this case, they already had this product that supposedly you can buy from Apple. I don't know what they charge you, probably 40 bucks, where there is a USB-C port, an HDMI, and a USB port. As I mentioned to you, these are smart cables, so that in each of these paddles, there are these smart chips in there. So here's the host, which would be the PC. This would be the device. In here, and this is the paddle. So there's these marker chips that determines which way the cable is plugged in. And these are my friends from Etron that developed this part. So they could, you know, they're a fabless IC company, right? So they're in one of the asterisks there. What I'm trying to get them to do is maybe they can be a solution provider in the example where, you know, they could integrate all these three into a single one, which happens to be there already in a market. But maybe theirs have a solution that's a packaging solution, a heterogeneous integration that creates a much smaller paddle. Is that something the customer cares about? Maybe. Me as a user, I would care about it. Maybe I can now do 2 sets of these and the same thing in the same volume. So again, you got to think through what your value add would be, but that's how you create possible solutions that the customers might care about. And then you got to look at, can I make it cost effectively? Can I make money? What does it take to get to market? Who's going to copy it? All of those things that I was telling you about. So what does all this mean in terms of your skill sets? I would say if you can define your own, I like pictures, right? If you haven't understood yet. So if this is your skill set, you're an analog designer, look at things that are within analog. There's more disciplines here, right? So um, let's just stick with analog. So let's say you're an analog designer. Try to understand where that applies, things that are adjacent to what you're doing. Okay, don't want to become a physical layout design expert, right? You want to take that and understand how this gets applied in a analog mixed signal chip. How does that get shipped? You know, so the integration of that circuit design with the chip level, with the package, might be a good adjacent discipline, right? And then the next level up here, how you can integrate that into a multi-chip package, for instance. So expand your skills into adjacent technical areas. That's the key message here. And then, in addition to that, what I would recommend is building what I call soft skills. This means you ought to be able to make the best presentations. Engineers are not so good at making presentations. Learn how to do that. Practice that while you're working at a big company. Make the best presentations. Your boss will be happy. Your peers will be happy. Your boss's peers will be happy. And that's how you promote yourself in the, or make advancements within the company. And by the way, while you're doing it, you're building all the skills that are required to do a startup. Networking, get involved with SSCS or whatever professional organization, meet people. The more they like what you have, the better opportunities that'll create for you. Build the relationships. Program management, by the way, is extremely important. It's really been helpful in my career, is where it lets you look at the adjacent disciplines. If you become a program manager for a product, then it's not just your analog design, but how that fits into the product. You got to build together, bring together experts from different disciplines that are going to make successful shipment of that product. Develop the multidisciplinary know-how. And by the way, having a mentor is a good idea. If you can find somebody that's 2 levels up from you that takes a liking as you're making the presentations, establish that relationship, because a lot of times they can give you guidance that'll help you progress in your company. So here's an example of what I've done in my career. It's a sample size of 1, right? So as I told you, I started off an implant engineer. I think I built the first all-implanted bipolar transistor at Motorola in 1975. And that was a big accomplishment for me, but I wasn't going to stop there. I looked at what the device characteristics are going to be, what the reliability, how that applies in the rest of the world, blah, 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 right? Did modeling characterization, worked on soft skills like program management. I think I was the first, the program manager for the first single chip processor chip, or processor module at Unisys in 1989. So, you know, that was a big accomplishment. It pulled together system people, circuit designers, packaging people, everything had to fit together. Got promoted into engineering management, senior management, ended up running the worldwide design services at Cadence for Silicon Design Services. And by the way, there, we had been a cost center for 20 years at Unisys, and when we got acquired by Cadence, the CEO said, hey, you got to go make some money. I had all these relationships with the industry people and showed them all our capabilities, and they said, oh, great stuff. And I would say, well, what would you like to buy? Oh, no, you know, it's that happened 2 or 3 times. I said, wait a second, something is not right here. And so we did a go-to-market strategy, which means just the thing I was talking about. What's the problem? What's our solution? What does the customer really want? And based on all of that, we ended up with 3 product lines. We went from 0 to $30 million in 3 years. Quite an accomplishment. When I then left Cadence and started my own business, I did the same thing. I figured out what the customers really needed, how that matched my skill sets, my team's skill sets, and that's how we launched TCX. an entrepreneur. I've started a couple companies and did this virtual operations consulting services. So I have no regrets. It's been a good career for me. Could I have done things differently? Absolutely. But no regrets. And by the way, as I said at the beginning, if I were to re-enter this field, I would have no problem being in the semiconductor space. I think the challenges are phenomenal. I think you've got to open your mind as to what you want to do and how you want to do it. I wish I had a talk like this and Professor van der Spiegel's talks when I was growing up, but you know, that's water under the bridge kind of thing, right? So learn from what you're hearing, and I would say do some soul searching. Figure out what your strengths are, what you really like to do today and maybe in the future. Identify the opportunities, both near term and long term. Focus on what you are doing. Get good at that, because that's really what people reward you to, right? For. If you're a good circuit designer and you're promoting yourself, you get rewarded to do that. That could be a platform then to go to the next level. But keep an open mind. Don't get hung up with, oh, I'm an analog designer. I don't want to think of anything but analog design, right? So just be open-minded and go for it, because you got nothing to lose. Here's a couple of pictorial examples. In football, you know, American football, there's this guy that's the ball carrier. He's got to find the right holes in the defense and make it through. Is one way to look at it. Be opportunistic, find the right solution, right situations. And here's one, a soccer game where, you know, you got one little angle here to get the ball in the goal, and that's maybe how your career looks like, right? So I would say overall, I think the industry has been good to me, and I think it's got a great future. At least certainly the rest of my career, my lifetime, and hopefully for your careers. But again, be aware, because a lot of the predictions may not come through, but if you're building your skill set, especially in the entrepreneurial space, you can be an entrepreneur in no matter what space, right? In restaurants and start a hotel, whatever, right? So if you got the right basic principles, you can do it. Certainly lots of business and technical challenges. The opportunities are phenomenal, and make meaning out of your career. Good luck. So that's the end of my presentation. What I will do, like I mentioned, if there's somebody that wants to share their idea, I'll be glad to listen, and we can take your feedback and give you some feedback on how you might go about it. Any volunteers? How about the HKUST team? You want to share what your idea is? No? I don't want to force you, only if you're comfortable. Any questions? Oh, we finished a little bit earlier, yeah?
Okay, for a startup company, normally we have a limited resource, right? So we have to focus on the small area. But for a company growing, we need to target on the large market opportunity. So, but it's very difficult to balance these 2 points, you know. So, and then comments. And from your speech, I think the market is the first important things. It's more important than the technical aspect. Am I right? And then actually, it's very hard to do a startup company if this area is have a large market share. The big company will come in and they will get killed because you can compete with the big company. So it's a lot of question or maybe your small team cannot handle at the beginning. So any comments on this? Thank you.
So it's a good question. As I understand it, what you're saying is if you're a startup and you create a product, a big company can come and wipe you out. Is that the question, right? So absolutely. So what that could happen, like I said, if it's something that's a good product that has a high volume, expect to have competition, right? So you got to be differentiated. If you're creating something new, you are the first on the market. It's differentiated. You certainly always have a short window before competition comes in. Usually in that short window, you can charge higher prices than when competition comes in. But again, if you're anticipating it, you won't be surprised and you'll be in good shape. I'd be careful about going into a product that directly competes. Let's say you're doing a processor chip that Qualcomm can come in and wipe you out, right? That's not the space to be in, right? Create yourself a niche that a digibag, the example I showed you, who's going to come compete with you? So how you decide what product to build is very important. If you're going head-to-head with a MediaTek, you're in trouble. I could tell you that even if you're starting to think about it, right? Now, having said that, there are situations where you can create a product that, yeah, maybe MediaTek or Qualcomm can compete with you, but if the volume is not large enough, you can create a niche. You can solve a problem for a niche, and you can position yourself that way, at least for a little time, and then, you know, move on to something else. I don't think that's a reason why you don't do things. I think you got to be smart about it, and you got to get people that can have experience and can provide you the right advice. If you're certainly going after head-to-head with those guys, you're in trouble, right? So it's a good question, though. Any other questions? You want to say something? So introduce yourself and tell them what the idea is.
Hello, my name is Dipyaman Modak. I'm from HQST, but yeah. So like I did my MPhil from Hong Kong University of Science and Technology. My work was on battery management system. So I believe like in this era of technology, while the lithium-ion batteries are the like most obvious choice because of its high energy density and like yeah. So I believe, yeah, I'm a bit nervous actually. Like yeah. So
You're doing good.
yeah. So so in my MPhil, my work was on like how to extract the information of the battery. So I did a chip. I designed a chip to determine the state of the charge of the battery, basically to know the percentage of the battery. And while doing this, I do a lot of research and did a block diagram. And I found out that the state of the charge is necessary in all the blocks in the battery management system, be it like in the battery charger. So suppose the battery is charging, so like we still need the state of charge in information, like to know how much is the battery percentage, because like in a battery, like to make the battery so basically, all right. So basically, in a lithium-ion battery, it can sustain for a long period of time between a certain percentage of charging and the discharging level. So suppose if you have a battery of 100%, then it can last a longer time. Like if it is charged till 90%, but and it should be discharged till 20%. So like at that point also we need a state of charge. Then like when 2 or 3 cells, suppose like you want to run a big system, so you need 2 or 3 cells in parallel. So, but when a battery is charging, so like.
So let me stop you for a second. That's a
Yeah.
good idea. So what you're saying is you have a circuit that determines the state of the battery charge,
Yes.
right?
Yeah.
So you want to start a business doing this, right?
Yeah. No, like my point is like I designed this system, this state of charge system with a 0.35 micrometer process, and in the market there are like this TI and Linear Tech. They're doing it with the help of ADC. But what I did was I just I used a different kind of technique. And there is one more paper who has done this thing, but they have done it 40 nanometer. And what I did was in 0.35 micrometer. And my results, like which I achieved, is not much better, like, but better than them, like in some aspects. But my point is like, how can I like sell this thing? Because it's just a small portion, like in a big world.
Okay, so that's good. Great technical accomplishment, right? Sounds like they're doing it with a 0.4 technology. You're doing it 0.35. They're using ADC. You're using a different technique, which is fine. So technically, let's assume you got a superior solution compared to them. Okay. If you want to make a business out of it,